Today we are going to learn about mastering real-time data streams with Apache Kafka. You will gain skills in setting up, configuring, and utilizing Apache Kafka for efficient real-time data processing. In today's digital age, the ability to process data in real time is not just an advantage but a necessity. Real-time data streams allow applications to provide timely insights and make instantaneous decisions, which is crucial for sectors like finance, healthcare, and e-commerce. In this video, we'll explore how Apache Kafka, a leading platform for real-time data streams, can be used to efficiently manage and process large volumes of data. By the end of this session, you'll know how to set up and harness Kafka's capabilities for real-time predictions and data handling.
Apache Kafka is a distributed event streaming platform capable of handling trillions of events a day. At the heart of Kafka are producers, consumers, and brokers. Producers send data to Kafka, which is stored in topics. Topics are partitioned and replicated across multiple brokers to ensure data availability and fault tolerance. Consumers read data from Kafka, either in real time or at their own pace. Kafka's architecture allows it to process high-throughput real-time data streams efficiently. Major companies like LinkedIn, Netflix, and Uber use Kafka for various tasks, from monitoring user activity to tracking application metrics. Setting up a Kafka environment is the first step towards mastering real-time data streams. Begin by downloading the latest version of Apache Kafka from its official website. Kafka relies on Zookeeper for managing configurations, so ensure Zookeeper is installed and running before launching Kafka. Once Zookeeper is up, start the Kafka server. Next, create a topic, which acts as a channel for data streams. Use Kafka's command line tools to verify that the setup is functioning correctly. Test by sending and receiving messages to ensure the environment is ready for data streaming applications. Kafka topics are fundamental to its messaging system. Producers send data to a topic, while consumers read from it. Kafka's Producer API facilitates the publishing of messages, allowing users to define the topic, key, and value. For data consumption, the Consumer API enables subscribing to topics, reading messages, and managing offsets. Offsets are critical as they track the consumer's position within a topic, ensuring no data is missed. Kafka supports various serialization formats, including JSON and Avro, making it flexible for different data types and structures.
One of Kafka's powerful applications is in the realm of machine learning. By integrating Kafka with ML models, we can perform real-time data preprocessing and predictions. For instance, Kafka can stream user reviews to a sentiment analysis model, providing immediate feedback. The Kafka Streams API enables the building of real-time applications that transform and process data in motion. A practical example is using Kafka to collect and process social media data, which is then analyzed by a machine learning model to gauge public sentiment, offering businesses timely insights for decision-making. Data consistency and fault tolerance are critical in real-time data streaming. Kafka achieves this through data replication across multiple brokers. Each topic partition has a designated leader and several followers, ensuring that if one broker fails, another can take over. Configure the replication factor based on your fault tolerance requirements. Consumer group rebalancing is another mechanism Kafka uses to maintain data consistency, especially during failures or consumer addition/removal. By storing data on disk, Kafka ensures durability, making it a reliable choice for critical applications.
Scaling Kafka to handle high-volume data streams involves several strategies. Kafka's architecture supports horizontal scaling, meaning you can increase capacity by adding more brokers. Partitioning topics allows for distributed load across multiple brokers, improving throughput. Adjust the number of partitions and replicas based on your scaling needs. It's also crucial to optimize producer and consumer configurations to manage data flow efficiently. Monitoring tools like Kafka's JMX metrics and third-party solutions such as Prometheus can help track performance and identify bottlenecks in the system.
To effectively use Apache Kafka, adhere to best practices. Start by designing efficient data schemas to reduce overhead and improve processing speed. Properly manage topic configurations, including segment size and retention policies, to optimize storage and performance. Implement security measures such as SSL encryption and SASL authentication to protect your data. Regularly update Kafka to benefit from the latest features and security patches. Automate Kafka operations using tools like Apache Kafka Connect for data integration and Kafka Manager for easier broker management.
While Kafka is a robust platform, users often encounter pitfalls. One challenge is message loss, which can be mitigated by configuring acknowledgements and setting appropriate retries. Performance bottlenecks may arise from improper partitioning or inefficient consumer logic. Address these by monitoring system performance and optimizing partition strategy. Consumer lag, indicating delayed data processing, can be resolved by adjusting consumer group settings and scaling consumer instances. Efficient disk space management is crucial, achieved by configuring appropriate log retention policies. Finally, ensure data consistency by managing offsets and replication settings carefully.
Let's look at a practical case study where Kafka is employed in real-time fraud detection. In financial institutions, detecting fraudulent transactions in real time is crucial. Kafka streams transactional data as soon as it occurs, feeding it into an anomaly detection system. Machine learning models analyze these transactions, flagging suspicious activity instantly. Kafka's ability to process data with low latency enables immediate actions, such as alerting security teams or freezing accounts. This integration not only enhances security but also builds customer trust by preventing potential fraud in real time. To leverage Kafka's full potential, advanced configurations are often necessary. Tuning broker settings, such as adjusting buffer sizes and log segment retention, can significantly enhance performance. Optimizing producer settings involves configuring batch sizes and compression types to improve data throughput. For consumers, fine-tuning fetch sizes and session timeouts can lead to better data processing rates. Configuring Kafka streams allows for real-time data processing within Kafka, while Kafka Connect facilitates seamless data integration with external systems. These advanced configurations help in achieving optimal performance and reliability. Kafka's ecosystem is vast and includes various tools and integrations that extend its capabilities. Popular tools like Kafka Connect and Kafka Streams enable data integration and processing. Kafka's integration with big data platforms like Hadoop and Spark facilitates enhanced data analytics. Additionally, Kafka is compatible with cloud services such as AWS, Azure, and Google Cloud, allowing for scalable and flexible deployments. These integrations make Kafka a versatile platform suitable for diverse applications, from real-time analytics to complex data pipelines in cloud environments. In conclusion, mastering Apache Kafka opens up opportunities to efficiently handle real-time data streams, providing timely insights and decisions for modern applications. We've explored Kafka's architecture, setup, integration with machine learning, and strategies for scaling. By understanding Kafka's capabilities and best practices, you can enhance your data processing pipelines. We encourage you to dive deeper into Kafka's ecosystem and experiment with its advanced features. Look forward to our next video, where we'll explore more on optimizing data streams. Thank you for joining us on this journey to mastering real-time data streams with Apache Kafka.